Bote, Lenzo Lampangi, Bote. I just wanted to say Matondo to be here. If you've made it so far to our sixth modules, that's great. We wish you a wonderful journey into this experience. So before we get started, I just wanted to take some time and repaint the big picture and put everything in context. So first of all, um, we are recording these lessons as a support to a written material we produce for our November and December 2023 hackathon. We are doing this as DITC, which stands for Disruptive IT Cameroon. And DITC is a co-op operating under DIA. DIA, which is the big umbrella under which we operate here in Cameroon. We do have a few other companies under DIA, but the IT cooperatives of DIA, the only one so far is DITC, again, which stands for Disruptive IT. DITC is in strong collaboration with WADA. WADA is a network of hubs present in multiple countries in Africa, whose goal is to bring Web3 technology in Africa. We share the same goal. And so I just wanted to take a few minutes and paint that big picture to put everything in context. So today we're going to talk about data structure, the different data structures that we see in distributed ledger technologies. There are basically three that I identified. There's obviously more, but these are the most significant, at least to me, I hope. Blockchains are the first one, and they are basically what we call a linked list for those who have done a little bit of programming. We'll get more in details very soon. The second one, model or structure, is directed acyclic graphs, which refers to the concept of graphs that we see in mathematics. The last one, which is very rare, is hypergraph, which is kind of like a generalized graph, still in the context of mathematics. So now let's move on to seeing in a more specific way how they are structured data. So blockchains are made up of blocks, and those blocks are linked together with a chain, hence the name blockchain. Now, at a practical level, the structure, the blockchain function on top of is simply what we call a linked list, which is really the most sought after data structure when it comes down to handling dynamic, data. It's a linked list at a basic level consists of nodes. The data, what we call data here, elements are nodes. As you can see in that picture. Each node could be can be thought of as two pieces. The first piece is the actual data in the node, and then the second piece is a reference to point to the next node. So hence the concept of a blockchain. So block would be represented here by a node which has some data, in our case, a bunch of validated transactions. And then this link here would be the mechanism through which a blockchain, connect one block to another block or attach a new block to an existing chain or blockchain. And we will get into that later in the course, how this is made specifically. So in order to summarize what we just went through, a blockchain is nothing other than a linked list in terms of data structure. Now, a linked list as a data structure is a linear structure. And it definitely comes with some shortcomings, especially in the case of a blockchain, because this data structure grows over time. And since members in the network needs to have a copy, a full copy to have the full truth, it can become quite impossible for those at the edge of the network, meaning has those who have like small smartphones or whatever, to grab the full copy of the ledger. Blockchains, although they are technically decentralized, are still centralized to some extent, because you have this one massive entity blockchain holding the truth and everybody is referring to it, which really doesn't make a full sense, given that people can organize themselves into aggregate and have their local truth. I'm hinting here at the possibility to having a blockchain of blockchains, which is something we will talk more about in our future modules. But that's just one downside of this structure. Yeah, and I will get back to other shortcomings of this structure. The next structure that we will look at is a directed acyclic graph, or a DAG, which is basically made up of vertices and edges. When you look at this structure, what we call vertices are these little squares, and they represent transactions. So if we start from here, and what we call edges are those arrows which are pointing to other transactions, to those vertices. A direct acyclic graph just means that we can get a closed loop in here. So something like coming from here and going there and coming back to this. No, it's not possible. They're all going in that directions, as you can see. And this is a really loose data structure, and it has many scientific uses and computer science as well, hence DAC-based distributed ledger technologies. And it comes with a lot of advantages. In this structure, instead of having one massive blockchain that can be only validated by one person at a time, that then broadcasted into the whole network, over here we can have a parallel validation, which is incredibly good, in the sense that if a validation could be happening in this portion, in that portion, you are basically multiplying your processing power by 3. So this network can get pretty fast in terms of, you know, the time it takes to validate a transaction, and they can also have a massive what is it called, throughput, in a sense that you can validate multiple transactions in parallel. Uh, Naturally, they come with a downside that we will talk more about in our future lessons. But one obvious downside is that these networks can be exposed to, you know, attacks. And IOTA, which is a blockchain that implemented this structure, later on had to adjust it and make it less of a distributed thing, network, but a bit centralized, to bring in a component that helped them tame down the risk of this structure being attacked. Uh, so that's it for this second structure. Now let's move on to our last structure. Before we get started here, I just want to say that a hypergraph, I think, a field in mathematics that I'm personally really interested in. And, you know, to all the developers that will be following this lecture, um, I humbly suggest that you really look into this data structure because in my research, uh, I haven't seen any structure in blockchain that can answer the many challenges we have over here in the local context of Africa to, you know, just design a blockchain that would fit the reality we live in. Nature or communities in Africa organize in a fractal way, and um, there's always the notion of, you know, grouping by affinity. So you have these little groups that come together and form groups, and that those same little group come together and form like even bigger aggregates, and then you have those levels. And I think this is something that can definitely be achieved by this structure. So the difference between graphs, as you can see here, and this one structure is very easy to spotlight. When you look at this, what's happening is that um, we have edges, those lines, and vertices. As you can see, one edge uh, can only connect two vertices, no more than two, which is the same thing we observe down here. Over here, in the case of a hypergraph, this is one hyper edge, and you can see it connecting one, two, three, four vertices. So that's the particularity of a hypergraph. Um, you know, there are great, I think, blockchains out there that have these structures. One specific blockchain I would recommend you look into is Constellation DAG, which strangely is not very well known from the public. But I will invite any serious developer to look into their white paper and see if he gets, you know, the concept. I think it's amazing what they are trying to do or what they did. Um, you know, and for that, let's move on to looking a bit into how their network is structured. And I will warn you, this is a bonus part. You don't have to dig into it. It's a little bit complex, but I think it would be interesting to take a look at it. And in advance, I will say sorry for the quality of the text. I couldn't find better, but yeah, we'll do with it. So at a basic level, this is how the network is organized. So I'm gonna do a quick overview, nothing serious, and then we'll read through it if we can and try to make sense of it. So at a basic level, we have something that they call state channels, which is really already incorporated into their architecture. This is something that most blockchain nowadays try to implement through side chains and state channels. So what happened is a blockchain such as Ethereum was built without thinking about this concept. So they have like one massive blockchain, like you can like we'll get to here, which looks like this. And then later they realized that not everyone at every time needs to have this whole block in order to validate its transaction. They can have like local spots of people who have a certain degree of affinity coming together and validating this transaction and then bringing it up to a higher level where you have another like grouping based on a certain level of affinity and then grouping it up again, organizing everything in tiers in such a way that the final block is just holding the truth of the whole network. What's great about this architecture is that these you know are totally separated and they can be performing validation and transaction in parallel without causing any problem to other subnetworks. And this massively increase the throughput and the number of transactions that could be performed per second. And this is something that I think Cardano, as the time I'm registering this, is working on with Hydra in such a way that the user would be able to perform transaction kind of off main network, if I can put it that way. And then at some point, take a snapshot and bring it into the main chain. It's a feature we've been waiting for because that's a real feature that can unlock a lot of use cases, both in Africa and my guess would be in many other countries in America and so on. So that's it for this module. I hope you were able to, take something. Next time when we meet, we'll be focusing on a specific case study in a farming context, because one of our goals is really to make sure that all this teaching that we are providing is meaningful in the local context, meaning the Cameroon context, African context, and why not elsewhere. But we start from where we are at. Thank you very much. See you later.